Welcome back to Think Design Work Smart. I'm Alex Bolbak and I'm coming at you from the Mosaic Work Studios. And what I have for you today is an answer to a question. And the question is, can we fix designs by changing the organization? And the answer to this question comes as a result of an article written by Mattias Verraes. If you don't know Mattias Verraes, he has been on this channel. We've interviewed him. He's very preoccupied about design and about good design. He has experience with domain-driven design, works in a community around domain-driven design, helps organize DDD Europe, and has written first a few essays and then a book with Rebecca Worfs-Brooks. So a lot of interesting things. He's very preoccupied by these things. I definitely encourage you to watch the conversation I've had with him around the domain-driven design, and not only, because it's been very, very interesting. And we have reacted in the past to a few of his articles, his essays, because they are very, again, very insightful. Which is why when I saw this article, I found it very intriguing. And I like to discuss this because it comes at a point where more and more organizations are starting to use what's called the Inverse Conway Manoeuvre to improve designs, or in the hope of improving the designs of their systems. And briefly, I've read the article before, and Mattias is arguing that actually you cannot. So Conway's law and applying Conway's law allows you to build good designs when you start from scratch, but when you try to redesign a system, applying the inverse Conway maneuver is something that might help, is a tool in the toolbox, but it doesn't prevent rigid designs. It doesn't apply to rigid designs. Okay, so this would be the brief for this, but I have a few thoughts about this as well, and it's very interesting to go through the article. Now, first of all, let me explain a few things for those of you who are not familiar with these topics. Conway's law, it's a law stated, let's see if we can find, I think it's in it's a law stated in April 1968 in a book, in a paper, How Do Committees Invent, by Dr. Melvin Conway. And he observed that the designs that organizations produce tend to mimic the communication structure inside the organization. So here the common examples that I give is, let's assume you have one team that is working in one office, and it's a relatively small team. Okay, maybe it's not, let's say, the agile style team of 7 people. Maybe you have, I don't know, up to 30 people or so. But they are all located in the same location. It's easy to go to another person, ask them directly questions. What do you think would be the natural code structure or architectural pattern that they will use when they start a new system? And the answer is most likely it will be something resembling a monolith. Because in a monolith, in order to change something, you need to be able to ask people that are very close to you, and to ask people about the changes that you plan to make and if they break anything. And if those people are far away, it's much more difficult. if those people are near you, then it's very easy to go get answers to your questions. Particularly if you know them personally, it's much easier. So this makes the system to work, to tend to map to the communication structure, right? The communication structure in these teams will be much coupled, much close, and so the code will do the same. Of course, it doesn't mean that all teams will produce something resembling a monolith, because if you have a directive to go with microservices or something like that, you'll go with microservices. But it's likely that those microservices will also be more coupled than in the case where those teams are far away. The other side of the coin is, what if you have one team in Australia, one team in US, one team in India, one team in Europe? What do you think will happen then? Well, it's likely that you'll end up with some kind of components that are split between the different teams, and each team is responsible for a part of the system, or for a component, or for either distributed or as part of the whole. Maybe it's a plugin based system where a team takes care of the core and other teams plug in various things. Maybe it's a distributed system, or maybe it's just a monolith, but a monolith that has different components, and each team is responsible for one or more of the components. So in this case, once again, you'll see this mapping because teams will find it very difficult to communicate. They will tend to separate their own thing from the others. And so you can see how the structure of communication will push designs in certain directions. And because of this, something called the Inverse Conway Manoeuvre appeared, which is, instead of fighting Conway's law, what if we take advantage from it? As far as I can tell, one of the first applications of this, before it was called the Inverse Conway Manoeuvre, and actually without it being a reorganization, was in some of the first projects on microservices. And the idea on that project was that we want to scale up the number of developers very quickly. And one way to do that is if we can decouple teams, pairs of developers actually, that can work on their own thing and get it done, and then get another thing to work on and get that done, and then get another thing and get that done, and so on. And without being dependent and without needing to communicate too much with the other pairs. But in order to do that, what you need to do is decoupling at a large scale. You basically take the large system, you figure out which are the smallest pieces that you can kind of carve out by using domain modeling and domain-driven design techniques. You turn them into services that you deploy and that communicate through events, because this is the least coupling you can have. And you end up with a system that is, in theory, highly scalable in terms of numbers of developers, and also has a bunch of other advantages. And of course, there's a trade-off. You have a bunch of costs allocated with this model and challenges. But if we just focus on Conway's law, this is just a way of using Conway's law in your advantage. But in this case, it was a new project as far as I know. Now, the inverse Conway maneuver is about restructuring an organization based on the design that you would like to have. So kind of trying to synchronize the architecture with the organizational structure, but coming from the architectural side. And it's something that is more and more popular and probably applied by various organizations. It's something that's been discussed for many years as a theoretical way of organizing, in particular, agile organizations, because you can restructure, you can play around with the teams, right? You can say, kind of keep the same teams, but reorganize them and give them different parts of the system so that they better match the architecture that is the best fit for your problem. And that would be the inverse Conway maneuver. Now, as a funny aside to this, I saw a tweet once, I think it was a tweet. But it was really funny because somebody was saying, okay, so Conway's law says that architecture is driven by the organization structure, and organization structure is driven by HR. So basically HR drives the architecture. And I found it really funny. Of course, it's not 100% correct, but it rings some truth. And it might explain why some of the systems are not architected in the best or most fit way. I'm avoiding saying best architecture because there is no such thing. There's basically a most fit architecture depending on your trade-offs and on your constraints, or even better, it would be the least worst architecture. That's the most you can do. But okay, so this is the general context, and the argument presented here by Mattias is that this maneuver has some limitations. So let's see, what are those limitations and why? The impact of the inverse Conway maneuver is constrained by the flexibility of the system. A reorganization can't fix a broken design. The inverse Conway maneuver is an organizational engineering device. It tells us to change our team and organizational structure to achieve the system design we want. More and more organizations reorganize based on this idea, and yet they don't end up with the system they'd like. What are we missing? There's evidence of the maneuver being applied. GitHub, for example, is a distributed company that built a tool for distributed collaboration using GitHub to build it. While systems do mimic their organization structure, changing the organization doesn't seem to have the same effect. That's because we are not accounting for the properties of the system under design itself. And that's a very important thing. It's important to look at the system structure and the limitations of it. And I'll give you some more examples here that are simpler in order to help us understand. Theories are systems. In his paper, Dr. Conway describes a structure-preserving relationship between the linear graph of the system to the linear graph of its design organization. He uses a much broader definition of system than just software system. His is more in line with systems theory, where, loosely defined, everything is a system and everything is part of the system. Yeah, so in system theory, a system is basically defined as having inputs and outputs and the black box in the middle. At least that's what I learned in university. And that's it. So it can be a software system, it can be an organization, a company, it can be government, it can be the human body, a lot of different types of system. For example, Conway writes, it may be less obvious that A theory is a system in the same sense. His example involves investigators who form a theory of how a plane crashed. The investigators create sub-theories of different events leading up to the crash based on their area of expertise. The structure of the theory will mimic the communication structure of the investigator's organization. Oh, that's very interesting. So, actually, what Conway's law, and I didn't realize this until this moment, but Conway's law is much more general than just software. It's like the result of the organization will mimic the communication structure. That's interesting. So maybe even the documents that your organization produces or the products that it produces in a more broad sense, like if it's a bank and it produces, I don't know, financial products, maybe those will also map or mimic the communication structure. Very interesting. I'll have to think about this. A software system doesn't live in a vacuum. It's embedded in the organization that produces this system, and it's governed by the theories we have about the software, how it works, what it does, why it does that, how it's all connected. We call these theories models and architectures. In some organizations, these theories exist only in people's heads. Others express this in diagrams and documentation. It's even better when they give continuous attention to collaborating and evolving these models, for example, using domain-driven design. But whether you have diagrams or not, everybody who uses or designs the systems has some theory of that system. Without modeling these theories explicitly, we not only risk having a badly designed system, we risk having wrong beliefs about the system. I think, yeah. So maybe one thing that I would add here is that there will always be tacit knowledge. And this is something that we've learned a long time ago. And tacit knowledge is basically knowledge kept in people's heads. It's impossible to capture the knowledge today. Maybe it will be at some point in time. So basically, collaboration is necessary because otherwise you will end up with wrong beliefs about the system. Examples. Over a decade ago, I was consulting for a SaaS company, software as a service company. I discovered that the belief of how the system worked varied wildly between the CEO, the salespeople, the customer success managers and trainers, the customers, and the engineers. If you immediately assume that the engineers had the best theory, nope. They understood so little about the design, which was largely created by their predecessors, that they wiped and rebuilt the customer dashboard database nightly. Ooh. It was the only way they could get some consistency in the results. Wow, ouch. So I've seen this happening. I work with an organization that was working on a large project, and that project has been started by a completely different organization with a completely different team. There was some kind of hostile takeover of the project, and then some of the people who are kind of in the second generation when the takeover occurred left. And basically the only person who knew something about the design of the project was a person who has not been there from the very beginning, has not been there in the second generation, but this person was like in the third or fourth generation of developers that passed through that project. And the knowledge was so diluted that basically the analysts had very little idea of what they were analyzing. The architects had very little idea about what they were architecting. The testers didn't know what they were testing. when we tried to write automated tests, the testers were, first of all, they were afraid for their jobs, and then they understood that, there's a lot of work to write automated tests, so that wasn't a problem. But the second thing is, when we tried writing, is okay, so you input this data in, how do you know that the result is what you want? It's like, I just look at it and form an opinion, and that's it. So there was no clear connection between the inputs and the outputs. It wasn't documenting anywhere. Nobody knew anymore what was the expected input, the expected output for a specific input. And these situations, I think, are the hardest to recover. I don't exactly know how you can recover from the loss of knowledge. It's a very difficult problem. And it's similar when I hear organizations giving to a new team, take this project and please rewrite it in 3 months. It's like, it's virtually impossible because you know nothing about how that code works. Okay, if you have some experience, then fine. But I've seen this when the team had no idea about that project, how it worked, and so on. And they were only given, this is the source code, documentation, whatever documentation they had, and, rewrite this and make it better. You cannot really do that as fast as people expect. And because the fundamental issue here is knowledge. If you don't have enough knowledge about the system, it's very difficult to compensate it. You need to manage the knowledge in your system. So I've seen another example of this happening. Another example is a client of Alding, a B2B company operating in a domain with complex regulatory requirements. Alding, I don't know what they are doing. When founding the company, the CEO, a domain expert, and the CTO agreed that the CTO would not get engaged in the domain's complexity. Instead, the technology will be built in a way that allowed the tech to remain agnostic of the domain. To do this, the engineers built a form builder, a rule engine, and a templating language. They hired non-technical domain experts and taught them how to use these tools to build customer-facing features. Oh boy. So while in theory this sounds great, I can already see some problems. Fast forward to a few years later, this theory about how the company should work now permeated everything from the system design to the product of the organizational control structure. But there's only so much you can do with forms and rule engines. Features that could easily be built with those tools had fast turnaround times, but everything else had to be done by the engineers. This required budgets and prioritizations and was often done through shortcuts, which in turn made subsequent changes even harder. The whole setup was making it impossible to achieve certain growth goals. The teams had no autonomy and required a lot of alignment to achieve anything. Could a reorganization solve this problem? Even though the system design had mimicked the communication structures that were put in place in the early days of the company, the system was now too rigid to be affected by a mere shuffling of the teams. And this is where I think the crux of it is. This example is very, very interesting. And yeah, developers are very tempted to build frameworks, tools, higher level abstractions, basically, because this is what they are. The problem with abstractions is that they are limited. Okay, and we're dealing with abstractions anyway, don't get me wrong. But one of the key things we learned in domain-driven design is that if your abstractions match the domain model and stay as close together to the domain model as possible, then it's less likely that you'll have problems. because the domain model or the domain will tend to stay relatively stable compared to the other things, the user interface, the database, the technologies, and so on. So if you manage to understand the domain model, which will change in time, okay, because domains evolve, right? There are new things that come up in the domain all the time. But the speed of change in the domain tends to be lower than the speed of change in technology. So if you manage to get a grasp, an understanding of the domain, it's easier to create designs that are less rigid, that are more flexible, that will adapt better to the changes in domain. Moreover, there are some, due to the cognitive structure of people, the way domains change is in a way that is understandable. Domains change based on the existing things, right? It's very rare that you get a complete innovation that completely wipes out everything in a domain and you start from scratch. Actually, I'm not sure. Yeah, probably it happens, but I can't think of an example here. So if this rarely happens, basically the changes in the domain will be built upon things that are already in the domain. The changes will be iterative, which allows you to make iterative changes in your domain model as well. If you try to avoid all this and kind of go abstract, go meta, and say, okay, we'll define meta entities and forms and rules engines and stuff, they can only go so far because these break at some point. And another thing is that by doing this, you are basically creating a new programming language, more or less. But it's a programming language that's less flexible. It's used by people who are not used with programming. And yeah, you end up with the wrong abstractions, fundamentally, and a very rigid system. So in this case, you need to rethink your design. And here's the crux of it. If you keep the same people who have used the same things, and then you come and say, okay, we need to reorganize the teams and restructure the design based on these new principles, it's going to be very difficult for them to do that because they will still be anchored in the old ways. It's very difficult to imagine sometimes how this new system will look like. And so this is why I think if you want to do something like that, and I've seen organizations try, the only thing I know it could work is if you bring in enough people who are fresh to this problem and with an expertise in, let's say, in domain-driven design in this context, who will be able to create the necessary structure and kind of drive the organization forward. Now, how many is enough? Well, you need a critical mass, and that's very difficult to define. Sometimes you need to have 100%, like double the number of people. Sometimes, well, if you have good influencers, maybe you need just 20%. But those 20% need to be able to kind of push the organization. Unfortunately, this also leads to issues with people leaving, being unhappy, and so on, because there's a change happening. Okay, so it's very difficult to manage these things. But basically, the only thing I've seen working in such contexts, bring in some fresh minds who are able to drive the change. Otherwise, yeah, very difficult. Even with trainings, even with coaching, even with consulting, it just, the system, if it's too rigid, it requires a lot of energy to move forward. That's maybe another way to put it. Whenever you want to change a system, fundamentally, like we are discussing here, you need to use a lot of energy in order to create this change, because the system is rigid. So you basically need to break the connections, break the rigidity, break out of it, metaphorically, okay, not physically, and then have an infusion of energy that is enough to not only do this, but go beyond this and keep the momentum, start a momentum that will then move forward. And part of the energy, how can you bring this energy, where you can bring in energy from consultants, from coaches, from different information, YouTube channels, talks, changes in practices, a reorganization of the structure, but also from new people who are coming in and working with developers. So now what's the best recipe for this? No idea. And my feeling is that it will be very contextual to your organization. But the key thing here, if you think about making a fundamental change to your design and it's very rigid, probably the inverse Conway maneuver is not enough. And what you need is to infuse a lot more energy that you would expect towards change. And that energy might mean money, might mean time, a combination of the two, people, skills, a number of things. And basically the way you do it is you try different things. You see what's working, you amplify that. You see what's not working, you dampen that. So fundamental complex system, complex adaptive system theory changes. Okay, but let's go back to this. Rigid systems. Advocates of the inverse Conway maneuver tell us that all we have to do is to reorganize teams to get a better system design. But if the software itself, the socio-technical environment that creates it, and the beliefs that the people hold about the system are all systems in their own right, and they're all impacted by the organization's communication structure, then applying the maneuver becomes a lot more messy. To intervene effectively in my two examples above, you have to address the organization, the systems, and the theories that people hold about the organization and the system. Interesting. So, yeah, organization, absolutely, restructure. Systems, which means practices and the way of work. And the theories that people hold about the organization and the system. And I think this is where you need people energy, let's say, to divest from the long haul theories to the new theories about the organization and the system. And that's where coaching plays a role, but not only. Well, depending on the rigidity, you might need additional things. Software is supposed to be soft, that is malleable, easy to change. Often it's not, because these systems are usually deeply coupled and interconnected. Changing one component has ripple effects not just in the software components, but in the entire ecosystem of organization and its customers. If this rigidness of our software is one of our main bottlenecks, you'd think we'd be eager to address it. And yet a disappointingly low amount of software organizations give enough attention to deep structural improvement of their software. So, yeah, people rarely think that there's a whole ecosystem around your product. If you change a component, this might change components that are connected to it, the user interface, but also the behavior of users in your product. So this is impacting a lot of different things, and you have to consider those. Once again, some of them are unpredictable, and so the way you do it is by incremental change or by testing it beforehand with users and seeing what the expected reactions would be. Another thing that I like to add here, this reminds me of another adage, which is when teams are called to redesign, or they would like to redesign a system that they produced. And the theory here is that, okay, they didn't have enough time to do it properly. They learned as they moved along, and now they have enough knowledge, and if we would just give them some time, they would be able to make the system better. Problem is, while it is a function of knowledge and time, obtaining good designs, it's also a function of skills. So if the team is having the same design skills now as they had in the beginning, or very similar, it's very unlikely that by redesigning they will obtain a better system. They will just obtain a system that doesn't have some of the issues that the previous system had, because they know them and they will actively avoid those. But it will also have additional issues that they didn't think about because their design skills were at the same level. So, the problems will move around. Some of them fixed, but new ones will appear. And that's basically how it happens. Okay. Instead, they turn to reorganizations. So software organizations, instead of giving enough attention to deep improvements in their software, they turn to reorganizations. And it is a tempting promise: change your organization, get the system design you want. Get the system design you want. It even comes with a loss, so it can't fail. However, as a CTO at a client once told me, we are reorganized, but the systems didn't get the memo. That's a good one. There is a redeeming factor. Managers can only impact the software system indirectly, and their only tools are meetings and reorganizations. Yeah. So, well, I don't fully agree here. Okay. I think managers should consider another model, particularly in agile organizations. I have a whole theory about technical leadership, but in principle, what it says is what you have in agile organization is you have teams that you should treat as a complex adaptive system. And then you have a higher level of a complex adaptive system where teams together communicate, collaborate in various ways. And this is the next system, the next black box. And you basically have inputs and you get some outputs. But due to the rules under which complex adaptive systems seem to work, and what we know from systems theory, you have another tool, and that tool is constraints. And particularly what you're looking for is constraints that allow better results, enabling constraints. Okay, so constraints that enable good results. For example, one example of constraint would be we need to use test-driven development for every new piece of code in our system. Okay, this is a constraint. It's a constraint that you set on teams in order for them to be enabled for better outputs. And what we mean by that, what would you expect from this? It usually works, but I'm sure there are situations where it doesn't. Is, okay, if you give them, let's assume that these people learn how to do TDD correctly, they practice, and now they start to do test-driven development in their context. What you would expect is, because of faster feedback times, you'd get better designs, fewer lines of code, more changeable code, fewer bugs. It might happen that the time to develop slightly increases, but the time to debug decreases. So there are other things that you might expect. Another enabling constraint, continuous integration. Or if you work with feature branches, or if you work on the main branch. All these are various levels of constraints, and technical managers, and I think some of these should be a CTO level because they are strategic in nature, should be able to set constraints that apply to multiple teams or to all the teams within a specific context, because not all these constraints are enabling constraints in all contexts. For example, if you are building hardware plus software, you might need a different type of enabling constraints. I had a client once who I helped with defining these enabling constraints, and their problem was we are doing hardware and software. And now, let's say if we want to do Scrum, but the hardware kind of lags behind, and then we need to implement software reactively based on the hardware changes. And so we started discussing, and there are various ways to deal with that. You can increase the sprint time. Let's say you set a constraint on the hardware to push changes every 2 months, let's say, so every 8 weeks. And then the development team can choose between having 2-week sprints, knowing that every 4 sprints they will need to make some changes due to the hardware changes. You might have a flow model, like a Kanban thing, where you just get the changes and you structure it in this way, and have some way of communicating. Or you might say, okay, maybe we don't need 2-week sprints, let's have 4-week sprints, and we'll have 2 sprints, and so on. So there are various ways in which you can deal with this. But my feeling is that managers feel that their only tools are meeting and reorganizations when they actually have one more very important tool, which is enabling constraints. Now, the key here is to make sure that they are enabling constraints and they are not disabling constraints. One example of disabling constraint would be every commit to this specific branch needs to go through John. This will be a disabling constraint because it just slows things down. John becomes a bottleneck, and then you need to figure out ways around the bottleneck. So there are ways of dealing with systems like this, but you need to upgrade the way you think about this and move to thinking in systems instead of thinking in I'm a manager and these are the things I can do. No, I need to manage these systems, these complex adaptive systems. I know I cannot say at every point in time what is the connection between a cause and effect. I don't have that. It's impossible. But what I have is this system has a disposition. It tends to move in a certain direction. And the way I know what disposition it has, okay, there are different ways, but one of them is by looking at results. The other one is to use what's called as probes, which can be metrics or one-to-one meetings and so on. So you use these things to figure out what the disposition is. And there are also tools for that if you are a larger organization. And then what you can do is to set up certain constraints, verify their effect on the system, and then amplify or dampen them. I mean, you start with one team, try that constraint, see whether it works better or not. If it works better, you amplify by moving to different teams, for example. So enabling constraints is the tool that you should be using in addition to this. And if your managers don't know about this, we have a whole learning program that helps them. All right. Extending Conway's law to account for rigidity. Is Conway's law wrong? No, I don't think so. It holds true when designing a system from scratch, which is what the paper describes. It holds true when working with a flexible system design, flexible enough to adapt to mimic the new communication structures. But it doesn't transfer well to existing systems with rigid designs. I propose this. The system design will mimic the communication structures of the organization, but only as much as the flexibility of the design allows. Dr. Conway commented, I think of the relationship between communication structure and system design as a constraint and no more. What you can change by messing with one side of the other depends on their specific characteristics. Okay, so let me pause here briefly because my feeling is that people think about Conway's law as a complete synchronization or an almost perfect synchronization between the communication structure in our organization and the design, the result, the system design of the organization. And I've always seen it as more like a tendency. Like if you leave this system in its natural state, without any other intervention, without any other constraint, this is kind of where it will try to go. So generally, if you put one team of 10 developers in the same room, give them some requirements and tell them complete freedom, do whatever you want, but give me this application that works, what you will end up is most likely something resembling a monolith. But it's what happens most likely because this does not take into account their education, their past projects, their experience, what they would like to try to play with, and so on. So Conway's law just states a possible or the most possible tendency of the system. It doesn't say this will always be in sync. However, what we see in practice is that when these things are very far away, then you start having different crashes, different issues. You start having like more meetings that you need to. You start having more conflicts, more bugs, more, there's all kinds of things that appear because of this. But you can definitely play around with both sides of the equation without necessarily influencing the others. And now it's interesting that he is thinking that Dr. Conway says something slightly different. I think of the relationship between communication structure and system design as a constraint and no more. As a constraint and no more. This means that the communication structure constrains the system design. And I'll have to think about this, because if you see it as a constraint, what it means is that the system design cannot evolve past a certain level, which is constrained by the organization communication structure. And maybe that's true. I mean, it's probably true, because this Dr. Conway is pretty smart, so, and he's been thinking about this for a long time. By consequence, the inverse Conway maneuver needs to be extended as well. If the system is new or flexible, change the organizational structure to get the system design you want. If the system is rigid, emphasize design work. Or more aphoristically, a reorganization won't fix a broken design. Conway's law is undervalued when it comes to the design of new system. Very important, I will repeat this. Take into account Conway's law when you design a new system. The communication structure of your organization will definitely have an impact on the design. So think how these two interplay. So Conway's law is undervalued when it comes to the design of new systems, but overstated when it comes to the redesign of existing systems. And that's the key to me. A greenfield project has unlimited flexibility, but as the design cements in more coupling and interconnectedness, it loses flexibility. We need to think about organizational structure early and continuously, not only as an afterthought when the design has ossified. Preventing our systems from becoming rigid requires constant attention, from the thousands of small local design decisions to large-scale architecture. To support and enable decision-making, we need good models of theories about the system, the domain, the product, the ecosystem it serves. And when we do find ourselves with a rigid system, the inverse Conway maneuver is just one of the engineering devices we can use, not a magic wand. In the end, good design is what leads to well-designed systems. Thanks to Dr. Conway for encouraging me to publish this. Great. Very interesting. You did it again, Mattias. Good work. So, a few thoughts in the end. I think we've learned a few very interesting things about the Conway law and about the relationship between design and organic communication structure. I think we've learned that these are not 100% in sync. So if you just organize the communication structure, you won't necessarily get the design you want, and presumably the other way around. So if you design, what would be the other way around? Well, the design does not have an impact, but the design will be constrained by the communication structure. These two are not 100% in sync, but you should be thinking about the structure of your organization when trying to build a new system. And don't underestimate the skill required to create good designs. I think that's the key here. So, and if you are in a context where you have a very rigid system, you might need to invest energy, to infuse it with a lot of energy in order to break open the rigidity. And this energy comes in a few forms. It can be time and money. It can be skills. It can be trainings. It can be people, talks, inspiration. But you may also need a bunch of new people who come in with a different vision and that push beyond the rigidity of your system and help you push beyond the rigidity of the system. Also, as a technical leader, remember this. And by technical leader, I mean this should be, top specialists in your organization, top specialists on various things, but should also be technical leaders of various levels, whether it's a technical lead, software architect, CTO. These are people who, in my view, should master this theory of enabling constraints and actually apply it daily. You should be able to look at the constraints, change them, adjust them all the time in various parts of the organization in order to figure out how to turn them into enabling constraints and how to move the system forward. That's part of technical leadership. Of course, this is for larger organizations. If you're just a team of, 7 developers, it doesn't make much sense. These things will be kind of negotiated, discussed, and will move much faster. But for larger organizations, it makes a lot of sense. So don't count on reorganization to fix a broken system. You need something more than that. And that's what we learned in the end from this article. Really cool. Great article. All right, that's it from me this week. What do you think about this? Let us know in the comments. As I mentioned before, one of the perks of this channel, if you ask a question in the comments, you might get a video answering it. So maybe you have some questions. Also, we are planning to do a video on the impact of AI, in particular LLMs, on software development, current and future impact. And it's pretty difficult to grasp the whole problem here. Of course, we have some ideas, but we value your input. So if you have any open questions about where AI goes or any opinions, just post them in the comments. There's a community post where you can write down. And there are also other ways to contact us through the MosaicWorks website or mosaicworks.com or through the email address tdws@mosaicworks.com. All right. With this being said, that's all from me today. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.